Okay, so continuing with part C here, I know that if I want to find the derivative of m, that I'm going to have to use product rule here. And then it wants the derivative at 2, so after I find the derivative, I'm just going to plug in 2. So I'm going to take the derivative of the first function, so I got to find the derivative of g of negative 2x. So the derivative of g of negative 2x is g prime of negative 2x times the derivative of negative 2x, which is negative 2, times h of x. Okay, so just so you know, and I'm going to erase this in a second, this is the derivative of g of negative 2x, right? So it's the derivative of the derivative of the outer, inside left alone, times the derivative of the inner, right? We got to use chain rule there. And then plus, copy the first function times the derivative of the second. So you get that. Okay. And so now I'm going to plug in 2. So I get g prime of negative 4. Because it'd be negative 2 times 2. So this is negative 4 times negative 2 times h prime of 2. Times h of 2 plus g of negative 4 times h prime of 2. Okay, so g prime of negative 4, I know that I go to negative 4 here. So I know that this is going to be negative 1. So this is negative 1 times negative 2 times, and I'm going to have to figure out what h of 2 is. Okay, but just so continuing with the table, I know that g of negative 4 is going to be 5, right? So this is plus 5, and then we had already said this in part C that the derivative of h at 2 is negative 1/3. Okay, so how am I going to figure out h of 2? Oh, sorry. Okay, so going back to here, I need to figure out this y-coordinate. Now, they want to know specifically that y value, so you can't just give an approximation. All right, there is a way of finding this y value. If we write the equation of this line, right, if I write the equation of that line, then I should be able to use that equation of the line to find the y value at that point, right? So we know that the slope of that line is negative 1/3, because we answered this already. So the slope of this line segment is negative 1/3. And then we know the y-intercept. The y-intercept is 0, 0. So in other words, I know that that line is going to be y equals negative 1/3 x plus 0, because the slope is negative 1/3 and I have the y-intercept, so I'm just using y equals mx plus b, right? So throwing it back to algebra 1. And so now I can use that to say, okay, when x is 2, I know that y is going to equal negative 1/3 times 2 plus 0. So that means that the y-coordinate is negative 2/3. So I know that this point, h of 2, is negative 2/3. Okay. So this is negative 2/3. I do believe that you didn't have to actually show out the work that I showed on that graph. So if you just answered negative 2/3 and it was correct, then they did give you the points. So you don't need to show out your work as to how you got to that answer using algebra 1 skills. However, if you want to do it off to the side to the reader, that's okay. But they really should just be looking at this. Okay. So now it says, is there a number C in the closed interval -5 to -3 such that G prime of C is equal to -4? So this shouts, is there a number C that this is an existence theorem? So I'm thinking that this is going to be MVT, IVT, or EVT. And in particular, I'm assuming that this is going to be MVT because it's asking me about the derivative of G. Okay, and what they gave us is stuff about the function G. We know G is differentiable, and of course they gave us a table of values for G, right? So I'm thinking for this one that I'm going to use the mean value theorem. I'm going to use MVT. So now I have to just recall what MVT says, and so you can look up the theorems and stuff in your review guide / notes. But really what it says is that if the function is continuous and differentiable on the interval given, then that means that there is some point where the derivative is equal to the average rate of change over that interval. Okay, so at some point, the instantaneous rate of change is equal to the average rate of change. Okay, so I need to, in fact, tell the reader then that this function is differentiable and continuous. I just have to make sure that they told us that somewhere. So they did. So I'm going to say, since G is differentiable, then G is continuous. Okay, so remember, differentiability implies continuity. All right, so it's important to tell the reader that we have that, right? Also, now what we're going to do is we're going to show that the average rate of change over the interval given is in fact equal to -4. So I have to check that G of -3 minus G of -5 over -3 minus -5, if that in fact is equal to -4. So I'm going to go back to my table of values. So I get 2 minus 10 over -3 minus -5. So that should be 2. So I'm getting -8 over 2, which is in fact -4. Okay. Now, since you told them that the function's differentiable, then it's continuous. We have differentiability and continuity. You have shown that the average rate of change does in fact equal -4. Make sure that you are using proper notation. And so we can say, so by mean value theorem, there is a number C, and just copy the statement that it was asking. Is a number C in -5, -3, such that G prime of C is equal to -4.